My name is Ryan.
Hey, my name is Young.
My name is Max.
And my name is Sydney.
My name Mario Simon, the team beat Dub.
Yeah.
Hi everyone, I'm here with Max Barnes and we are gonna interview him about our experiment. So what is our experiment about?
Alright, so today our experiment, we're going to investigate and experiment how sound travels through water. And so we're going to put water in a bowl and put it on top of a speaker and see which frequencies affect water the most.
Okay, so is it actually possible to see sound waves through water?
It's very possible actually, because in water the molecules are very tightly packed, whereas in air the molecules are spread out, so sound travels at around 1500 meters per second in water, which is 4 times faster than it travels through air, which is why marine animals are so easily able to communicate with each other in underwater, because sound travels so quickly. So in this next experiment, we're going to show you guys how sound travels with higher and lower frequencies of sound.
Turn the light out back there.
At 50 hertz, the water pops up with more force because lower frequencies travel farther away in water and all the frequencies are interfering with each other. Also, when the water pops up, the bubbles are pretty big because the waves of a lower frequency are longer than higher frequencies. At 100 hertz, the water pops up with less force than the 50 hertz because it's a higher frequency. Notice that the bubbles are made by the sound waves are much smaller than the 50 hertz because the frequencies are shorter. There are several other smaller sound waves than of the 50 hertz because of the frequencies. This is a big deal when it comes to sound. Notice how the water hardly pops up and the water just gets really tiny. G at 200 hertz are small waves, smaller than 50, smaller than 100 hertz. The forces are much more smaller. Okay, why does this matter? You care to explain what we did here again?
In our experiment, we are seeing the sound waves that are traveling when they come out from the speakers. They touch the water, and as soon as they touch the water, the bottom molecules of the water push up to the next water molecules, and they keep pushing up until they come out from the surface, and that's why they bubble so much when you have low frequencies, because when you have low frequencies the waves are much longer, and that's why more water molecules push from the bottom to upstairs, and that's why you have much more bubbles when you have lower frequencies. And when you have higher frequencies, the waves are just so small that they just push so little water molecules, and that's why they make just a little wave.
A little bit. Okay, that's good. Well, you care to explain how this will help us in our future careers?
Well, actually, this is very important to our degree because we as recording art students, we have to know how sound travels through any surface, how does it reflect, how do we get delays, reverb, etc. And when you are doing live shows and concerts and anything that has to be something with sound, you always have to be having those kind of problems that sound just gets absorbed on or gets reflected. So you have to really know well about these kind of things in order to have the sound that you want.
Okay, that's pretty cool.